Hello there, welcome to Tech. In this session, we are going to discuss about fire pumps. So what you will learn in this session, first of all, we have to learn and we have to understand about fire pumps, then about pump capacity, then in depth about pump head, and then pump power. So let's start. See, what is fire pumps? Okay. So remember NFPA 20, National Fire Protection Association 20 is the standard for the installation of stationary pump for fire protection. Okay. And the purpose of this standard is to provide a reasonable degree of protection for life and property from fire through installation requirements for stationary pumps for fire protection based. Okay. So a fire pump is an integral part of a fire sprinkler system as it provides high pressure water accessibility to the fire sprinkler system, increases the flow rate of the water. Okay. So fire pumps are an essential part of many water based fire protection system. For example, fire sprinkler system. Okay. So as part of a fire sprinkler system, a fire pump receives water from either an underground water supply or a water tank, lake or reservoir and is powered by electricity or diesel fuel. Okay, that is why we have a diesel engine generator also. Okay, the high pressure supplied by the pump distribute water through the sprinkler system and hose standpipes. So I think now all of you clear that what is the scenario of fire pumps. Generally you can say in a simple language, a fire pump usually refers to a pressure increasing component of the water supply for fixed place fire suppression system such as fire sprinkler, standpipes and foam system. Okay. Now they are used to increase the pressure of a water source when that source is not adequate for the system it's supplying. Okay. Now see how these pumps increase the pressure. First, this pump take the water from existing water source. After that, when a pump takes the water from existing water source, they increase that source pressure by a design amount, provide that higher pressure to fire protection system at a design rate of flow in GPM. Okay. Now the pump which is showing in figure commonly found in buildings with high pressure demand such as high rises or storage warehouses. Now the next topic is pump capacity. So what do you understand by pump capacity? The pumping capacity is the maximum flow rate through a pump at its design capacity. Okay. And it is written here, it is the amount of liquid that can be pumped per unit time, or it is measured in gallon per minute, cubic feet per minute, or in cubic meter per second. Okay. When you see in this figure which is shown here we have a less capacity pump and more capacity pump. Suppose if your requirement is more, if you want to pump or if you want to discharge water at more height, so on that time you have to select this more capacity pump. Okay, in more capacity pump you can discharge water at high level at higher height as compared to less capacity pump. So based on our requirement we have to select which type of pump we need. Okay. Now the next topic is pump head. So what do you understand by pump head? So it is the maximum height that the pump can achieve pumping against gravity. Okay. See, suppose in this figure here I have a pump and I have to discharge water to, this is my underground. Suppose this pump level is in the grade level. Okay. Pump is in the grade level and I want to supply water to my building overhead tank. So the maximum height, see, the maximum height that the pump can achieve pumping against gravity that is called as a pump head. Okay, here see, water is discharging and the maximum height the water which covered, okay, against gravity, that is called as a pump head. Okay, and it is generally expressed in feet or meter of the liquid being pumped. Okay, now see, when you see in this figure here, the maximum height that pump covered against gravity, how much? 5 feet. It means the pump which we have selected here, the maximum height they can achieve up to 5 feet only. So the pump head is how much? 5 feet. Okay, so this is about pump head. Now in a closed system, suppose in a closed system means what? In a closed system, friction is the only loss or head that the pump is required to overcome. So in this figure, when you see here, we have a closed loop. Okay, closed system is what? As I already discussed, or suppose in HVAC system, okay, we have a primary pump or secondary pump. Okay, so in that pump, primary and secondary both come in closed piping system. Okay, and the pump which we are using for condenser cooling tower, condenser pump, that pump comes under open piping system. So closed loop means, suppose here I have a pump. Okay, so in closed loop system, friction is the only loss or head that the pump is required to overcome. Okay, see here, we have a discharge head from pump center line to the where you want to supply, and suction head. So remember this point. In closed loop system, the height of water on the suction side of the pump is always exactly equal to the height of the discharge side of the piping. Okay, in closed loop system. Or in open loop system, when you see here in this figure, here we have an open loop system. The water which we are supplying na, from cooling tower, suppose in case of HVAC we are using condenser pump, that comes under open piping system. Okay, the piping going from condenser or from chiller to cooling tower, or from cooling tower to chiller, that piping comes under open piping system. And the pump which we are using to discharge water from cooling tower to chiller, condenser pump, that comes under open loop system only. Okay, so in open system there is always a difference in head between the suction side and discharge side of the pump. When you see in this figure here, we have a from center line of this pump to the top of the cooling tower, suction head. Okay, where you want to discharge the water up to that level is called as a discharge head. But suction head is what? To the center line of the pump up to lowest point of the cooling tower. Okay, so discharge head is equal to suction head plus what? HU. Okay, now what do you understand by discharge head? Actually, what is we express discharge in term of HD. Okay, discharge head expressed as a term of HD, but actually what is discharge head? So remember, it is the head at the pump discharge. Okay, simple. You can see in this figure here, this is my horizontal pump. Okay, horizontal stationary pump which we have used for our firefighting system. So here here we have a two line. One, we have a suction line and discharge line. So when water is discharging through this pump, so the head at the pump discharge is called as the discharge head. Okay, now when you see here in this figure, here I have, suppose we have an underground tank. Okay, in this tank water will coming from where? Suppose from municipality. Okay, and here I am using pump for what purpose? Because I want to supply water to overhead tank. Okay, top of the building, suppose we have installed this overhead tank. To fill that overhead tank we are using pump because we need pressure. So when you increase the pressure of this with the help of this pump, so automatically uh, water will supply to the overhead tank. Okay, so here we are using water. So for water, specific gravity is what? 1. So here that is written here. And here from this pressure gauge to top of the overhead tank, height is given 35 meter. Okay, so if I tell you that what is discharge head, so simple, you can say the vertical distance between the pump center line and the surface of the liquid in the destination tank is called as a discharge head. Okay, now we have a second figure. When you see in this figure, we here we have a brine. We are using brine and we have to supply brine uh, to the destination tank. So if you are using brine, so on that time specific gravity of brine is how much? 1.2. Okay, here also height is given same, h is equal to 35 meter. Now it is made up of the static head at the pump outlet. This discharge head is made up of the static head at the pump outlet. So I think all of you know about static head. Simple. Static head is it is the height that water has to travel and it's move through your discharge pipe. Okay, that is called as a static head. Okay, so it is made up of the static head at the pump outlet, and this discharge head is made up of any positive static pressure in the discharge side of the system and discharge pipe friction loss, any equipment pressure drop. Okay, a pump discharge pressure gauge, here we are using pressure gauge. In discharge line we are using pressure gauge. So what is the purpose of using pressure gauge? So remember here, a pump discharge pressure gauge would indicate total discharge head. Okay, now see here, what is actually suction head? Suction head is what? It is the inlet pressure of a pump when above atmospheric pressure. Okay, it is called as a suction head. When you see in this figure, here we have an underground tank. Suppose here we have a underground tank. Underground tank means suppose this tank is on the grade level. Okay, and here we have a pump in basement and anywhere. Our main target, we have to supply water to the overhead tank. Okay, so with the help of pump only you can supply the water, okay, to the overhead tank because we need pressure. So here when you see in section line we have a pressure gauge. See what is suction head? Here it is showing head resulting from elevation of the liquid relative to the pump center line. See, head resulting from elevation of the liquid relative to the pump center line. If the liquid level, okay, I think all of you understand that what is suction head. So head resulting from elevation of the liquid line related to the pump center line is called as a suction head. Okay, and remember here one point, if the liquid level, suppose here, if the liquid level is above pump center line, if your liquid level is above pump center line, in this case same, here in this case what happened, our liquid level is above pump center line. Okay, so static head is positive on that time. Your static head is positive. Up suppose if the liquid level is below pump center lines, suppose if you are selecting underground tank, suppose underground tank, we have to suck, we have to supply water from underground tank to overhead tank. On that time I am using pump in grade level. Suppose my pump is in grade level. So on that case what happened, your this liquid level is below pump center line. So on that case static head is negative. Okay, we have to take negative static head. And remember, negative static head condition is commonly denoted as a suction lift condition. Okay, see, and it is written here. Now another it is showing that what is discharge head actually. So I have already explained you the vertical line the vertical line or the vertical distance between the pump center line and the surface of the liquid in the destination tank is called as a discharge head. Now from this point to this point is called as a total head. Okay, now what is suction lift? As I discussed that negative static head condition is commonly denoted as a suction lift. Suction lift is what? The inlet pressure of a pump when below atmospheric pressure. It's called as a suction lift. Suppose uh, if this tank which is in grade level, suppose our condition is my tank is underground tank I have taken and the pump I have taken in grade level. I want to supply water from underground tank to overhead tank. So here from the if level of liquid is below pump center line. In this case what happened, level of our liquid is below pump center line, so it is called as a negative suction head. And this condition is commonly denoted as a suction lift condition. Okay, here it is given, see suction lift, it is showing suppose my pump is underground and sorry tank is in underground and pump it is in grade level. So on that time it denoted as a suction lift. Okay. Now in a closed loop system, means the pump, suppose in case of HVAC we are using primary secondary pump. So in a closed loop system, suction head is obtained by removing the following losses from discharge head. What? First we have to remove piping friction, and all of you know what is friction loss. This is the loss needed to overcome that is caused by the resistance to flow in the pipe and fitting. Okay, so it is dependent on size, condition and type of pipe, and numbers and type of pipe fitting, also flow rate and nature of the liquid. Okay, so totally this friction loss is depend on the size, condition and type of pipe, which type of pipe you are using. Based on that, next, in a closed system, suction head is obtained by removing the valve losses, equipment losses. Okay. Now a closed loop system in operation has a positive suction head. Remember, a closed loop system, the pump which you are using in closed loop system, such as suppose take as an example of this pump, primary or secondary pump in HVAC system we are using na, to pump up primary pump we are using before chiller, and after chiller we are using secondary pump. So that comes under closed piping system or closed loop system. So remember here, a closed loop system in operation has a positive suction head, not negative. It means in positive suction head what happened, how you can identify this positive suction head? If the liquid level, if the liquid level is above pump center line level, if the liquid level is above pump center line, that is called as a positive suction head. Okay, in an open loop system, suction head includes static head or lift, or entrance loss, friction head in the suction piping, any positive pressure existing on the suction site. Okay, an open loop system has negative pressure if the pump is placed above the fluid source. So okay, if your pump is placed, if you are placed your pump above the fluid, so it means it comes under negative suction head now, because I have already discussed if the liquid level is below pump center line, so that is called as a static head, and that static head we have to take in negative. Okay, and now here pump power. So what do you understand by pump power? In that, first we have a liquid horsepower. Actually, what is this liquid horsepower? It is the minimum power that is required to move the liquid. Suppose if you want to move liquid from one place to another place, so the minimum power that we required, that power is called as the liquid horsepower. Okay. Now it is written liquid horsepower is the power that the pump would require to move the liquid if the pump were 100% efficient. Okay. Now how to calculate this power? We have a formula. Power is equal to work done by pump to lift the liquid divided by time taken. Okay. Now suppose power we have taken P, and work done, we know that work done is what? Formula of work done is what? When you simplify the formula, when you apply the formula, you get the value mgh divided by T. Okay. M is mass. Okay. G is acceleration due to gravity, and H head. So here see, when you simplify this formula, you get this value. From where we get this value? We know that density is equal to how much? Mass upon volume. So if you want to convert this mass into density into volume, so just put the value of rho is equal to mass upon volume. So just simplify it, cross multiply, you get the value rho into V. Here rho is what? Density, and V is volume. Okay, remember. Here V upon T means volume upon time. How much? You can write as a flow rate. Okay. Discharge, because discharge formula is what? Q. Q is equal to AV, means volume upon time, and it is denoted in which unit? Meter cube per second. So that also already written here. P is equal to rho density into flow rate, mass flow rate into acceleration due to gravity to head. Now see, here we have a term. How we can denote it, all this term? So in SI unit, power is in which unit? We have to take in watt. Okay. And in IP unit, power unit is BTU per hour. Same way, for density, how much? Kilogram per meter cube we have to take in SI unit, and in IP unit, density we have to take in pounds per cubic feet. Okay. Now same thing here, for flow rate value we have to take in SI meter cube per second, and in IP cubic feet per second. And acceleration due to gravity unit is what? In SI meter per second square, and in IP feet per second square. Then head unit we have to take how much? Meter in SI, and in IP unit feet. Okay. So with the help of this formula, you can easily calculate the liquid horsepower. Okay. Now it is written liquid horsepower is equal to specific gravity of that liquid. Suppose if you are using water, so specific gravity of water is how much? 1 into GPM, gallon per minute, into H is what here? Head. Okay. Divide by 3960. You get the value. And note here everyone, specific gravity for water we have to take 1. Okay. Now what do you understand by brake horsepower? So it is the power required to drive the pump. The power which we need to drive the pump is called as a brake horsepower. Okay. In another word, or in other words, you can say it is the actual horsepower delivered to the pump shaft. Okay. Mathematically, it is equal to the liquid horsepower divided by the overall efficiency of the power pump. Sorry. So to calculate the brake horsepower, we have a formula: liquid horsepower divided by efficiency of the pump. And efficiency of pump we get from where? Again we have a formula to calculate this efficiency of pump: liquid horsepower divided by brake horsepower. We get the efficiency of the pump. Okay. Now efficiency of the pump is equal to power output or power input. So here we have a formula to find out the efficiency of the pump. Once you get the efficiency of pump, put the value in this equation, you get the brake horsepower value. Okay. So in this way we have to calculate the brake horsepower. Now the topics which we have covered in this session: first we have learned about fire pumps. Okay. Then about pump capacity, then what is pump head, we have learned that also, and what is the difference suction head and discharge head, suction lift, all that we have learned in pump head. Okay. Then we have learned about pump power also. So this is all about fire pump. So I hope all of you enjoy the session. See you in next one.